Okay, so we are going to practice drawing electron dots, or doing electron dot notation, and then drawing Lewis structures. The first basic Lewis structure we're going to draw is water, just H2O. And we're going to start by drawing the electron dot formation of all the elements in water, and then we'll go into drawing the structure itself. So I like to just do it in 3 steps. One is the electron dots. So first, electron dot notation. And keep in mind we are doing water. So electron dot notation is water. Or the elements in water, really. So hydrogen, that comes out to hydrogen, since it has 1 valence electron, because it's in group 1, its dot structure is just H with a little dot. We got 2 hydrogens, just draw them both. And then we got our oxygen, which is in group, it's either group 16, which that 6 tells you there's 6 valence electrons, or you can call it 6A. So 16 has 6 valence electrons. Everything in group 16 has 6 valence electrons. Now if you count all your dots, 1, 2, 3, 4, 5, 6, 7, 8, that's 8 total valence electrons. And that's step 2, is counting up your total valence electrons. Step 3 is just drawing the Lewis structure. So the Lewis structure. Now with Lewis structures, the first thing you want to keep in mind is what do you put in the middle if you do have more than 2 elements. In this case we have more than 2, so we got to figure out which guy goes in the middle. A couple exceptions are that hydrogen never goes in the middle, mainly because it only forms 1 bond. Carbon almost always goes in the middle. Since we don't have carbon in this guy, we know that based on hydrogen never going in the middle, oxygen is going to go in the middle. The main rule to remember is that the least electronegative element goes in the middle. That's the main rule to remember. So you can always look up electronegativity chart. Keep in mind that hydrogen is actually has electronegativity of like 2.1. So it's actually has a decent electronegativity. So he goes in the middle, and then you'll just want to start with single bonds. If single bonds don't work, then you'll move on. But just put your guy in the middle and start with single bonds. And then you want to satisfy the octet rule for everyone. Now hydrogen is an exception to the octet rule, where it only wants 2 electrons. Since each line represents 2 electrons, technically the hydrogens on the ends here have 2 electrons, so they're good. They are satisfied due to the fact that they want to be like helium, which also has 2 electrons. So in this bond here, each hydrogen, this guy and this guy, they have 2 electrons. And keep in mind, this line represents a sharing of electrons, whereas these 2 electrons that are being shared are technically in the possession of both oxygen and hydrogen. So hydrogen's good and hydrogen's good. Now oxygen is not an exception to the octet rule. It wants 8 valence electrons. Keep in mind, all of these dots over here represent valence electrons. So oxygen had started with 6. It wants 2 more. It gets those 2 more by sharing with 2 different hydrogens. So it's not done though. It wants a total of 8, and then we're talking about valence electrons here. So it needs to get 2 more pairs to satisfy the octet rule. So it needs to have 2, 4, 6, 8 total electrons on its valence shell. 6 of those electrons it already had, 2 it gained from these hydrogens. So that's a very simple way of drawing hydrogen, and if you ever learn about Vesper theory, you'll learn that hydrogen, that's not the proper structure to draw it, but we won't get into that just yet. So that's the Lewis structure. This comes out to be the Lewis structure for water. Just a very, very basic Lewis structure for water. You got bonds, 2 valence electrons, and you can double check your Lewis structure by comparing to the electron dots you had. Since you had 8 electron dots, or 8 total electrons, well, electrons aren't going to disappear. They're not going to be added. You should end up with 8. 1, 2, each line represents 2. 1, 2, so that's a total of 4 so far. So it's 4, 5, 6, 7, 8. 8 total valence electrons, so we're good. This is our valence structure. And the octet rule is satisfied with each element. So let's try real quick, we'll try something simple like methane. I'm sorry, I'm doing the numbering weird. Fix that. 1 and then 2. So methane. Methane is just CH3, or excuse me, CH4. So which guy goes in the middle? Or no, let's follow the steps I outlined up here. So the steps, again, electron dot structures, carbon's in group 14, so it has 4 valence electrons. 1, 2, 3, 4. And each hydrogen has 1 valence electron. That's 4 hydrogens. So that is a total of 4, 5, 6, 7, 8 valence electrons, just like with our water up here. So whatever our final Lewis structure is, it has to have 8 valence electrons. Again, what goes in the middle? Hydrogen never goes in the middle. And again, it's the least electronegative element. In this case, carbon. And again, hydrogen won't go in the middle. So we'll just put single bonds around this guy here. And you put your hydrogens on it. And with this guy, you don't have to add any electrons. Because if you notice, each line represents 2 electrons. 2, 4, 6, 8. The octet rule is satisfied by carbon. The hydrogen, each hydrogen has 2, 2, 2, 2, 2. So everyone's happy in this structure of methane. One last one we'll do is hydrogen cyanide. Again, hydrogen cyanide, HCN. And this is a pretty classic example too. So start by drawing out the electron dot structures. Hydrogen has 1, because it's in group 1. Carbon, it's group 14, so it has 4. Nitrogen, it's in group 15, so it has 1, 2, 3, 4, 5. That is a total of 5, 6, 7, 8, 9, 10 electrons. So whatever our structure is, our final structure is, it has to have 8 total electrons. So which guy goes in the middle here? Well, it's definitely not going to be hydrogen. So what's least electronegative? Carbon or nitrogen. Carbon's least electronegative, so carbon's going to be the middleman. And again, carbon's a universal middleman. Carbon loves being in the middle of all of these compounds. Now let's first draw our single bonds, and you can put these guys wherever. I'm just going to put hydrogen on the left, nitrogen on the right. Now notice that hydrogen is already satisfied. Hydrogen has 2 electrons with this bond, so it's already satisfied. Nitrogen has 2, carbon also has, or technically carbon has 4, 2, 3, 4. So now you want to satisfy the octet rule for everyone. Hydrogen is good. Carbon has 1, 2, 3, 4, it needs 2 more. Nitrogen has 1, 2, so it needs 6 more to satisfy its octet. So is this a structure? Let's double check. Let's check our number of, do we have 10 electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. No, we have too many. Your only option when you have too many electrons is to add bonds. That's your only option left. You can't just have electrons added to your final structure. So you have to add bonds for this to make sense. So let's add 1 bond. Now you have to make a correction, because the octet rule says everything needs to have 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's too many, so you erase some electrons. Same thing with nitrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's too many, so erase some of these electrons. Now count them up to see if this is your structure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We still don't have the right structure because, again, it doesn't match up to 10. So add another bond. And again, keep in mind, you're not adding bonds over here because hydrogen's already satisfied. Hydrogen doesn't want any more bonds. Hydrogen never forms more than 1 bond. So you can only add bonds here. And again, we got to go back to the octet rule. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These guys are extras, so we got to get rid of them. Same thing with nitrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. He has way too many. Let's check. 1, 2, 3, 4, 5, 6, 7, 8. That is your structure for hydrogen cyanide. You can check by counting the total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That matches up with the electron dot total. And that's 3 examples of Lewis structures using electron dot notation.